this is like 113 is called function model selection and articulation assumption, okay, which is a lot of words, okay. The beginning function model selection is something we've already done before. This is determining if it's linear or quadratic or cubic based on the common difference, okay. That's the good news. We've done that before. The last time we did this, you gave the degree. Like it would say, what's the best degree? And you would say degree is 1 or 2. Now the only difference is we use a word. We use linear, quadratic, that kind of thing. The articulation assumption is something that comes to the second part. And this is where a lot of real world application comes. So there's a lot of word problems in this kind of stuff. We will do both with calculator and without. So if you want to get your calculators out, we are definitely getting to the point in which you have to use it. But we'll also talk about what would happen if it was on a non-calculator portion of your test, because it could be, at least the beginning questions could be both. So the beginning says determine the appropriate function to model a situation. So a lot of times you'll see the word model. The model means which would be best, linear, quadratic, that kind of thing. Eventually we will learn how to create these models. That comes in the next section, which is 114. And that's what your quiz will be on. So you'll get a quiz on 114, which is like all calculator based, learning how to do a regression model. That will be that's next Monday. So we know this, but the first difference, if the first difference are constant, then it is linear. If the second difference is constant, then it's quadratic. If the third difference is constant, then it's cubic. If I went more, it'd be quartic. And eventually we will also loop in here log and exponential. But for right now, we're going to keep it here. So this is just determining the appropriate model for the data and explain why it models the data. So the first thing you have to do is pay attention to the x values. What's happening? Are they increasing the same or decreasing the same? So as I look at these x values from -3 to -2 and -2 to -1 and -1 to 0 and 0 to 1 and 1 to 2, what's happening there? They're all increasing by 1. So it is the same interval, which is important. It also means I don't have to worry about putting it over 1 because the change in the y is going to be my rate of change. So 5 minus 15, -1 minus 5, -3 minus a -1, -1 minus a -3, and 5 minus a -1. And I end up with -10, -6, -2, 2, and 6. Are those the same? No, if they were, it would be linear, okay? That's first difference. Now I go second difference. So I go -6 minus a -10, which becomes +10. -2 minus a -6, which becomes +6. 2 minus a -6 -2 becomes +2. And 6 minus 2. And this is 4 and 4 and 4 and 4. Are those the same? Yes. So the best model for this would be quadratic because it's the second difference. Second difference is constant. If it asked for the rate of change, it would have been, well, the rate of change wouldn't be the same, but the rate of change of the rate of change would have been 4. All right, this one's different though, because look at what's happening with my x values. I'm going from -3 to -2, which that difference is what? 2. -1 to 0 is 1. 0 to 1 is 1. 1 to 2 is 1. And 2 to 3 is 1. These have to be the same. They can't be different, which means I can manipulate the data. I can actually ignore some data in order to make them the same. So if my first interval is 2, and then I want to go from -1, I can actually jump the 0 and make that a difference of 2. So I'm going to physically ignore the data that was provided in between there. So I'm making the interval the same. And then if I want to go 2 again, I would go from 1 to 3. And that difference is 2, and I'm going to ignore that. So I have to start at the beginning. I can't skip around. But I can ignore data as long as I've got enough to then compare rates of change. So now I'm going to go from -7 minus a -11. And if I wanted the rate of change, it would have to go over 2. If I'm just comparing them, I don't have to put it over 2 because they're all over 2. But if it wanted the rate of change, I'd have to put it over 2. Then the next one would be -3 minus a -7 over 2. And then the next one would be 1 minus a -3 over 2. And I'd end up with 4 over 2 and 4 over 2 and 4 over 2, or 2, 2, and 2. And that is my first difference, which means this would be what? Linear. First difference is constant. So if I was just comparing the change in y, as long as the change in x is the same, I didn't have to put it over 2. But if it had asked me for the average rate of change, now I would have had to make it 2. So I would have had to put it over 2. So be careful with there. You don't need the interval of the y as long as it's constant when you're finding if the first difference or second difference, but if it's asking you what it is, then you need it. Questions on that one? All right. Now we get to some real world stuff. Literally, it's the rest of it. Example 2 is talking about restricting domain and range. So it says a bottle rocket is set up on a picnic table. When the firework detonates, it will shoot straight up and come back down again. The height of the rocket is modeled by, and it gives you the function, where t stands for time in seconds and h is the height of the rocket in feet. First of all, think about what this looks like. If I'm talking about a rocket, right? So it's going to go on a T-chart. But a rocket on a picnic table means there's a picnic table here. And the rocket's going to start, it's going to go up, and it's going to come back down again. Now, it's a real-world rocket, which means it can't start negative, right? Time can't go negative, which means it's going to start at the y-intercept. It's going to go up, it's going to come back down, and it's going to hit the ground, and it's going to stop. Which means even though if I graph this, my function's going to go beyond the x-axis, my rocket would not. And even if I graph this and my curve is going to come back negative from my y-intercept or my y-axis, in real life, it cannot. Okay, we're not going to go backwards in time. So it says, for A, it says find h of 1, and what does it mean in this context? How do I find h of 1? I can just plug it in. So I would get -15, 1 squared plus 62 times 1 plus 2. And I get -15 plus 62 plus 2, -15 plus 64, which is -49. Not negative, positive 49, sorry. So that's the first part. The second part says, what does it mean in this context? So using this specific real world example, what does it mean that h of 1 is 49? Go, Eva. Good. So after 1 second, the rocket has reached 49 feet in height, or the height of the rocket is 49 feet, something like that, okay? It has to be in the context. So you have to talk about rocket, you have to talk about the 1 being in the second or the time, and you have to talk about 49 being the maximum height, and it has to be 49 feet. So that's what it means in this context. All right, B says, what's the restricted domain? So domain are what, the x or the y? The x. So what's restricting my x values here? We talked about it already, but can it go left of my y-axis? No. So the minimum my x can be is what? 0, okay? Can it be 0? Like, is the rocket somewhere at 0 seconds? Yes, so it gets a bracket. And then what would be the maximum value my x would be, or how would I find it? It's going to be this 0, right? It's going to be where it crosses the x-axis. So if this was factorable, I would set it equal to 0 and solve it if it had a quadratic formula. But obviously something on that kind of level, you can have your calculator. So you'll go to your function, you'll type it in as your y equals. So let's do that. My y1, -15t, which is my x squared, plus 62t plus 2. All right, so I graphed my function. First of all, this is what it looked like. -15 squared, x squared, plus 62x plus 2. and then I hit graph on it. Now I want to find where it crosses the x-axis, okay? So I'm going to go second, trace, and I'm going to go to my 0. And I'm going to arrow over. It's going up. It's coming back down again. I want to be left of my 0. I want to be right of my 0. And I want to go to the 0, which is 4.165. And that's where it hits. It does include it, so it gets a bracket. Questions on that one? Okay, while we're here, let's talk about how we could have checked f of 1 too, right? If I go to my second trace and I go to value, and I put 1, I would have gotten that 49. All right, let's go back. Ready? So now the next thing is, what's the restricted range? So now what are we talking about? In terms of a model, that is real world. What is range? The y, which in a model in real life would be? Height. So what's the minimum height our model can be? 0. It started at 2. It went up somewhere up here and it came back down. So it hits 0, which means the minimum it can be is 0 because it can literally be resting on the ground. Okay? But then how am I going to find the max? It's off my screen, right? So this is where I would say feedback from last year's kids. There's 2 multiple choice parts on your test. One was non-calculator. It's 28 questions and you have 80 minutes. You have a lot of time for it. The 12 questions is calculator based, and I think they had 30 minutes for it. I have to look it back up again, but I'm pretty sure it's 30 minutes. And they said they had ample time on the non-calculator part. They were not stressed on time. But the calculator part stressed them out. It is the comfortability level, and can I do it quick? So you got to get so comfortable with these calculators, which we're going to spend a lot of time on them this week. Like the next section is mostly calculator. You're going to get hopefully more comfortable. But think about, how do I get to these things quickly? Like, how do I find that value quickly? 1, I can zoom out on my calculator, right? I can click zoom out and I can find until the curve. 2, I can adjust the window, but I'm kind of doing like a guessing game there to see how high it goes. 3, you can look at your table values. So you got to figure out what works the best for you. But if I look at my table values, so if I go to table, I can look at what's happening with the y values. So they go up from 2 to 49 to 66, back down to 53. So I know my max is happening in between 2 and 3. Does that make sense? And it's happening 66, 53. So if I just like went to my window and I made my y max like 80 to see if I can get it all in there, now I can make an educated adjustment on the window, and I'm looking for the max value. So now I'm going to go second, trace. I want to go to the max. I go left of the max. I go right of the max. And I hit enter, and there's my maximum value, which you can't see because I moved it, which is 66.0666 or 66.067. And it hits that point, so it gets a bracket.
So 66 would be wrong, right?
Correct. You got to go 3 decimal places unless it says otherwise. Yep. Which well, actually, this doesn't have to be multiple choice. This could be open-ended. All right, now it says, what's the average rate of change on the interval for 1 to 3? So one way to do this is f of 3 minus f of 1, or h in this case, over 3 minus 1. The other way is let your calculator do the work for you. So we're going to go back to the regular menu. I'm going to do alpha y equals to get my fraction. I'm going to do alpha trace to get my y1, put in parentheses 3, minus alpha trace, get the y1 again, put in parentheses 1, and then it could be 3 minus 1 or it could be 2, whichever.
How did you do the fractions?
Alpha y equals.
Oh, okay.
You see it?
Yeah,
okay. And there I get my rate of change to be 2. So just that alone, like if you do it the long way or you do it the way we just did it, it could shave off a minute of time, which at the end of that like section could be very, very valuable. Questions? Okay. What is my rate of change, or what is this function determining? What are my units? Blank per blank. What does T represent? Seconds. What does H represent? Height in feet. So this would be feet per second. All right, now we got piecewise functions. I don't think these are that bad. Okay, they're weird, but they're not that bad. First of all, it says the graph of F below shows the price of a concert ticket during the first 10 hours that the tickets go on sale. The cost of a ticket starts at $80 for the first 2 hours and then increases each hour. This is clearly a budget concert, not like a regular one now. Right. All right, so first of all, this is a piecewise function, right? A piecewise function has different parts of the graph depending on your domain, your restricted domain or your x values. So it said it in the words, but what's happening from 0 hours to 2 hours, so the first 2 hours, my price was consistently $80. Then what happens at hour 2? It jumps up to 90. So from hour 2 to hour 3, notice these are going by twos, okay? From hour 2 to hour 3, it's $90. Then from hour 3 to hour 4, it's $100. And it goes 110. It goes all the way up to the end at hour 10. It stops at what? What's the highest it gets? 160. Okay. So number 1 or A says, what's the domain in this context? Domain is your x values, right? So in this case, what's domain? It's the hours, right? It's the hours the tickets go on sale. What's the restricted domain this time? What's the lowest x? 0. So it says at 0 and it includes it, so it gets a bracket. And then as I move from left to right, is it continuous? Yeah, so even though like this is an open dot, that's a solid dot. So there's no x value skipped, right? So then what's the highest x? 10. And again, it gets a bracket because it's an, oh, sorry, it doesn't get a bracket. It gets a parentheses this time because it's an open dot. What's the range in this context? This is where it gets weird, right? Because what happens as you're going up? Are there y values that are constant or that are continuous? No, it starts at 80, then it goes to 90, then it goes to 100. There's nothing in between. So we will literally list it. We will say it is 80, 90, 100, 110, 120, 130, 140, 150, and 160. And this time 160 gets a bracket because although the end is an open dot, anything that's here would count as a solid dot. So it overtakes it. God bless you. If you were doing this in like inequality, this would be 0 is less than or equal to x, which is less than 10. And then this, you would literally say y equals, and we would list it 80, 90, 100, and dot, 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 all the way to 160. You'd have to list them all. I'm putting the dot, 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 but you'd actually have to list it all. All right, then C says find f of 7.5, and what does it mean in this context? So what is f of 7.5? 7.5 is here. It is 140. And what does it mean in this context?
How much money the concert ticket is at 7.5 hours.
Good. So at 7.5 hours, the concert ticket costs $140. All right, now we're going to get into area and volume problems. So if you think about it, area would be length times width, right? If there's an x in each, that means it's going to result in a quadratic function. And volume, if a like rectangular prism or something like that is length times width times height, there's 3 units of measurement, which means it's going to result in a cubic function. So a lot of these will appear obviously in words. They will not give you rectangular prism, which is length times width times height, but they will give you, like in this one, they give you the cylinder. It says, suppose the volume of a right cylinder has height h, that is 4 times the length of its diameter d. Find the function v of r that represents the volume of the cylinder in terms of the radius. And recall that the volume equals pi r squared h. So first of all, it's not giving us the model. We have to come up with our own model, okay? using the volume equals pi r squared h. And it wants it in terms of the radius. So my variable is the radius, okay? That I know. What does it tell you in the beginning? It says that the height, right, is 4 times the length of the diameter. So it gives me nothing about a radius yet. But what's the relationship between a diameter and a radius? Radius is half the diameter, or the diameter is twice the radius, right? So if the height is 4 times the height of the diameter, then h equals 4d, which means the height is really what? 8r, or 4 times 2r. My goal was to get everything in terms of r, because it wanted it as a function of the radius. So now I can say the volume as a function of the radius equals pi. R is r, that stays, and my height is 8r. And if this was multiple choice, I'd look at my answers because that one might be there. And if not, it's going to rewrite it as 8r cubed pi. Either of those might be there. With me so far? All right, then the next part says, using the formula found, what's a reasonable domain and range for the problem if the diameter can never be larger than 12 centimeters? So what does that restrict? If the diameter can never be larger than 12, how does that help me in this function? This is by terms of radius, right? So if diameter can never be larger, can it be 12? If the words are can never be larger, can it be 12? Yes. So this is less than or equal to 12, which means my radius is what? Nope, other way around. It's half, right? Half. So less than or equal to 6. You with me so far? So that means the domain. So what's the smallest my radius can be? Can it actually be 0 and still have volume? No. So it will start at 0, but it will get a parentheses because it can't include 0. And the biggest it can be, we just said, because the domain is my radius, right? The biggest it can be is 6. Can it include 6? Yes, so it gets a bracket. So that would be my domain. This is confusing because I wrote D, and D could be diameter or domain, but that's domain. Now, how would I know the restrictions on the range? First of all, what's the smallest my range can be? 0, but can't include it, right? And then how would I find the maximum my range could be? I'm going to actually take that 6 and plug it in. So it'd be 8 times 6 cubed times pi. So this would be 8 times 2, 16 times pi. Without a calculator, I'd multiply it out. 1728 pi. Can it be that? Does it get a bracket or a parentheses? Bracket, because it can be that. It just can't be bigger than that. If this was with your calculator, then you can actually do 1728 times pi. And I would get 5,428.672. And if I was to look at this on a graph, like if this was on the graphing calculator portion, I would actually write this as my y equals, and I would look at my maximum value on my curve. So let's talk about what that would look like, because it's going to be weird. Graph that function. Graph, we wrote it as this, like 8, r is my x, cubed times pi. All right, so I'm going to graph it. It's a cubic function, right? Oh, man, I need to change this. If it's a cubic function, it should take on some sort of shape like that, right? Is there a restriction on domain and range on any cubic function? What happens to the arrows on the left and the right of here? Do they stop? No, Okay, so on a general cubic function, it's not going to be restricted. But in this case, we said it has to be realistic, right? So it has to be, an x can't be bigger than 0. I mean, less than 0, sorry. And it can't be bigger than 6. So I can take my function and I can actually restrict what it should look like by going to window and making it 0 to 6. And now I get that just that part of my function. If I didn't restrict it, there would be no maximum value. It would continue on forever and ever and ever, and my range would not be restricted. So that's why that's important, okay? So if I want to know what's happening where the max is this time, I'm looking for what's happening where x is 6. So if I go to my second trace, I can go to where the value is 6. I hit 3. Okay, so I went to value and I did 6 and it matches what we found, okay? So there are ways, obviously, if this was on a graphing calculator portion of your test, there are ways to use your graphing calculator to help you with this stuff. But if it wasn't, like you would keep it as 1728 pi. But that is something that you could do without a calculator, so just keep that in mind. You'll thank me when you get to number 1 in your AP classroom and you know how to do it. All right, so this is called, and shows up in a lot of the practice tests at the end of the year too. This is still real world modeling, but now it says a square of side x inches is cut out of each corner of an 8-inch by 15-inch piece of cardboard, and the sides are folded up to form an open-topped box. So think about what this looks like, because on the AP style question, it does not give you the picture. So you have to like literally visualize what this looks like. You have a piece of cardboard. Are you staring at your piece of cardboard? Do you see it? Are you visualizing it? Close your eyes. Picture the piece of cardboard, a rectangular piece of cardboard, okay? And then you want to cut a square. It's got to be the same size square, but in each of the corners so that you can like fold the sides up on your box to make a perfectly shaped open topped, meaning there's no lid, rectangle, okay? So if this is the box, hopefully this is what you pictured in your brain. You would take off these little squares and then these sides would fold up and these sides would fold up to make yourself this perfect little shaped box. Does that make sense? Okay. Now it says that you don't know the size of those x value. You don't know the size of the corners, okay? But what we do know is they're squares. So what does that tell you about each side? They're all the same. So the square of side x inches is cut out, which means this is an x. And this is an x, 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 and this is an x. And it would be all the way around. This would be x, this would be x, okay? Then it says that the original cardboard is 15 inches by 8 inches. Well, this looks like it's longer, so I'm going to make this my 15, and this looks like it's smaller. I'm going to make that my 8, but really it doesn't matter. So A says write the volume V of the box as a function of x. So volume is length times width times height for a prism, which is what this would be. So what is the length of this box if I took this and I folded it up, right? So I cut off the x and then I folded it up, which means I cut out what? X on that side and x on that side. So that length of my new box is going to be 15 minus 2x. And then my width was 8, and then I cut off what? 2x's again, which means my width is 8 minus 2x. And then what is the height of this box? How do I know that? We cut x, right? So this is x. If I fold that up, that's going to be the height on either side. So my volume as a function of x is v of x equals length, which was 15 minus 2x, times width, 8 minus 2x, times height, which is x. And if this was multiple choice, that might be written as an answer. If it's not, it might be expanded. Just be prepared for either. Still alive? Yeah. Oh, you're just scratching. B, find the domain of V as a function of x. Note that the model imposes restrictions on x. So what x is what my values are, right? So what's the smallest x could be? 0, but not including 0, right? Because it has to be something. It has to be some sort of length. Yeah. Because it can't be negative, right? But it has to have some sort of, it could be teeny tiny. It didn't say it had to be big. This could be a really, really short box, wide, but the height is really short, right? Or it could be almost the length of the whole thing, right? So if I were to take X off of here and X off of here, well, first of all, can X be 15? No. I need 2 X's off that 15, right? And then I'd need to take 2 X's off the 8. So can it be 8? No. But can it be anything less than 8? Yeah. So this goes to 8, and it gets a parentheses on the 8. It can be literally 0.001. It'd be the tiniest little box, either width or height, and depending on how you cut it. But that's the biggest, or the biggest it could be. Yeah.
Since it's 2 X's, wouldn't 2X equal 8?
Well, 2X can't be 8. Like 2X would have to be less than or equal to 8.
And so X would be 4.
No, because it's still like could be so small. It could be 0.001 on either side. Does that make sense?
No, like for the maximum that X can be.
The maximum it could be would be half. Oh yeah, half the 8, right? Yes.
Yeah.
X could be half the 8 because there's 2 of them. Yes. Does that make sense?
Yes.
Which you'll see when we do it that way. Hang on. There are 2 of them. Does that make sense? 2X has to be less than or not equal to, less than 8. Because there are 2 X's. Does that make sense? Yes? Okay. And it can't equal it, so it gets a parentheses. Now C says, use the graphing utility to graph B as a function of X over the domain found in part B, and then use the maximum finder to determine the max volume such a box can hold. So I'm going to go to my graphing utility, and I'm going to type in my model. To me, this is one of the most confusing questions that you'll see, but if you can understand it, wow, good job. You know what I'm saying? Like if I can teach you how to do this and you can get this question right instead of freaking out and skipping it. Okay, so first of all, let me go to my window. Okay, so as it starts, it looks like this. This is a cubic model. It's going up, it's coming down, it's going back up again, right? So as it is, I could not find a maximum because this would not end. My arrow would continue to point up. So it even says it like use a graphing utility to graph as a function of X over the domain found in part B. So I'm going to restrict my X to match that domain. So I go to my window and I go from 0 to 4 and I go back to my function. Now it's going above my Y equals 10, and then it's coming back down again. So if I want to find the maximum, I've got to either zoom out or I've got to adjust my window. One way or the other. If I go window, now I'm going to adjust the Y. I did 50, and it wasn't enough. So again, you can zoom out. You can look at your table. Oops, window. I'm going to just do 100. And now I see my curve go up and come back down again. It also matches, like, think about your domain. It's staying all positive. My X values cannot go, or my Y values cannot go negative. If that continues on, it actually comes below, right? So I want to find the maximum on this domain. So I go second trace. I go to my max. I go left of it. I go right of it. I hit enter. And it's going to bring me to the max. So the max volume would be 90.741. And what would this unit be? Inches cubed. All right, then B says, how big should the cutout squares be to produce the max volume on this box? So what did the what were the lengths of the cutout? What do we use to represent it? X. So what is this really saying? What X is going to produce the biggest Y, right? Do we have it? Yeah, it's the X coordinate on my max. So 1.667, and it's inches, would produce the biggest volume. So again, the AP Classroom will not give you the diagram. You got to kind of understand what it looks like. It will always be about the same thing. Like you'll see this again, like when we get into our review before the AP, these word problems will pop up, and sometimes they have that picture and sometimes they do not. So you got to kind of understand it in your head. This section, I will tell you, I'm not going to give you a bunch of word problems on your test, but you are going to get word problems, and this section is heavy in them. Okay? It's great for a Tuesday after your brains have been on break for 4 days. Yeah. Questions? Okay.